Everyone, and welcome back to Activity 32. Today we are going to talk a little bit more about magnitude, direction, and resolving our vectors back using magnitude and direction into component form. So as we've discussed in our earlier notes, we know that the magnitude of a vector can be found by using the basically Pythagorean theorem, the length and the width, if you want to think of, or the movements a and b, so square root of a squared plus b squared. Direction, however, we haven't talked as much about. This is that angle that our theta would be pointing at. And again, kind of thinking about like, oh, if this was at 0, 0, which quadrant this would be pointing towards, or is it pointing towards an axis? So again, we're going to use tan inverse, similar to what we did with the polars, to find the theta values. So some things to remember is what quadrant would this be pointing in based on your component form. You want to think about that as you are here. Or is it pointing towards, an axis value? So is it pointing towards 0, 90, 180, 270, something like that? So kind of going back to some things we've talked about, right? Is it 0, 90, 180, 270? Is it pointing on an axis? Or is it pointing towards quadrant 1, 2, or 3 where you might have to adjust, or 4? Okay, so keeping all of that in mind. So for our first example, we are given a picture. And notice if we kind of moved this vector to standard position where it's starting at 0, 0, it would be pointing down towards the third quadrant, right? So you want to keep that in mind, especially for that direction. Now the component form of this, this graph is moving to the left 14 units. So we moved from positive 10 over to negative 4, so that's a total of 15. And then down 6 units. So again, notice we were up at positive 4, moving down to negative 2. So that is a total of down 6 units for our component form. So what we could do from this is find the magnitude by taking the square root of 14 squared plus 6 squared. Again, make sure we are using parentheses around that. So we would get square root of negative 14 squared plus negative 6 squared. So we would be at about 15.2 if we were approximating, or that's the same thing as saying the square root of 232 on that one. And then for our direction on this one, we are going to take tan inverse, our b value divided by our a value. In this case, tan inverse of b divided by a gave us 23.2 degrees. Now we know though that this is pointing towards quadrant 3 from our given. So we have 180 plus theta. So that's going to give us, 203.2 degrees. Our second example, we have here a quadrant 2 value, right? We're moving left and up. So again, that'll be for our direction. We want to think of that. This time, the square root of a squared plus b squared would be the square root of 29, which we may need to approximate if need be. And then our theta value, we're going to take tan inverse of b over a. Well, this time when we take tan inverse of our b value divided by our a value, we get negative 68.2. Okay, that is not a quadrant 2 value that we need. Remember our quadrant 2 value, we would do 180 minus our theta value. So 180 minus 68.2 will give us 111.8 as our angle measure. The last one is for you to try then. Right, now we also want to be able to talk about resolving our vectors into their component form when necessary. So if we're given the magnitude and the direction, how do we resolve it back to component form? Well, you're going to take your magnitude times the cosine of your theta and the magnitude times the sine of your theta to get back into that component form. So for our first example, we are given 10 is the magnitude, direction is 30 degrees. So we know that 10 times the cosine of 30, which is square root of 3 over 2, will be our component A. If we reduce, that's 5 square root 3. B is going to be 10 times, oops, not the cosine, the sine of 30. And the sine of 30 degrees is 1/2. So 10 times 1/2 would be 5. So our component form for this one, 5 square root 3, comma 5. Our next one for vector z, notice our magnitude and direction. Our direction is not from the unit circle, so we're going to have to make sure we are in degrees mode, and we are going to just use our calculator to approximate. 15 times the cosine of 217 would be about a negative 11.978. Again, A is going to be magnitude times cosine theta. So we get negative 11.98. And then B will be magnitude times the sine of that angle. So 15 times the sine of 217, negative 9.03. And again, component form, we would write that as A, comma, B. All right, thanks everyone for watching. We'll work more with